So 44 on page 411. Very good. And 44 is 16a squared minus 56ab plus 49b squared. Again, you missed that class, so here it is. I have to go through these before I say or do or attempt anything. Okay, so first of all, I'm asking myself, what is it? So the answer is, what type of polynomial is it? Awesome. Then I'm asking myself if it's in descending order. And now the question is, wait a minute. What do you mean by descending order? I see two variables here. So which one what? Well, in A and B, if I see A and B, I see A squared, I see A and no A, I will consider this in descending order. Okay. Unless somebody says to us, no, B is the variable. A is not important. Then I will have to rearrange it. But nobody said that to us. So I will consider that this is indeed in descending order. Then I move on to the greatest common factor, which means I look at these three terms, all three, and see if I can pull out something. If it's a number or a letter or a number and a letter or anything. I don't think they do. That's true. 16 is 2 to the 4th. 56 is an even number, but this is 49. Right. So absolutely, 49 is 7 squared, so there is nothing. Good. So I'm moving on. Negative leading coefficient? No. The leading coefficient is positive. So now I know for sure that I should not be looking at this, and I should not be looking at this, because you already identified it as a trinomial. Okay. So now I have 4 more steps to go. I will see if this or this is applicable. These are the two special products. Since this is a negative in the middle, this is absolutely out of question. So I'm thinking of this. If it is this, now I have to make sure that this is a perfect square and this is a perfect square. Is this a perfect square? Sorry about that. Is this a perfect square? Yes, they both are perfect squares. So what will go in here then? And A. Right? And 7 and? Correct. So now, for the moment, I will disregard this, and I will say it appears that is a perfect square, trinomial. It appears. I don't know yet. What will go in there? 4a plus 7b, or minus? Exactly. 4a minus 7b. Now, I know from chapter 5 that when I expand this, I get 3 terms. Right. The middle term is 2 times 4a times 7b. Forget about the sign. We already took care of the sign. Okay. If that is minus, this is minus, I'm done. So 2 times 4 is 8. Yeah. 8 times 7 is 56ab. Right. Because this middle term is 56ab, if that middle term is 56ab, then I will say check, and I'm done. Right. If it's not 56ab, this is wrong. Now I look. Is it 56ab? Yes. Yes. So I will say this is the correct factor form. Okay. So every time I'm given a trinomial, I will always try one of these two before I look at the last two. This is not that difficult, but this is a long procedure. It takes a long time. So I always hope for a special product. Yes, it's part of the problem. I have to check the middle term. So 2 times 4 times 7 is indeed 56ab. Yes, with minus is the same. So that's the correct factor form. Good. Anything else from 1 through 100? You said 19? Yeah, 19? Very good. So let's look at 19. It's good to pick all different types so we can review this. Okay, so again, I'm going back to this quickly through my mind. Once you get used to this, this will go like this. Okay. First of all, I'm asking myself, what is it? It's a binomial. So obviously, I'm going to work on this, not on this. Just this. Okay. Is it in descending order?
Yes.
Correct. Greatest common factor? Very good. I have to pull it out. If I don't go through the greatest common factor and a negative leading coefficient, I may not be able to factor. Good morning. So what is left in parentheses?
X squared minus 90.
Careful.
Or 49.
49. Now I'm here. Negative leading coefficient? No. Now I'm here. Since this is a difference, I can only look at this and this. These two make no sense in this situation. So I can only think or ask myself, is it a difference of squares? Or is it a difference of cubes? Once we say a difference of squares, then we have to prepare two binomials. If you had said a difference of cubes, then we would have had to prepare a binomial times a trinomial. Exactly in the same way we determine these, we will determine these. Exactly the same idea.
Would it be like x plus 7 and x minus 7?
That's it. Very good. Next example, next problem. And this is it.
Maybe 21.
21 it is. 21. 21. I see. X squared plus 3x plus xy plus 3y. Perfect example. I'm back to my strategy. And I identify what type of polynomial this is. Exactly. So my strategy now is this. Nothing else. This makes no sense. Okay. So my first question is, it's a polynomial. Next question is it in descending order? Again, I'm having a little bit of a difficulty here because I see two variables. Okay, nobody says anything to us which one is more important. I also see that this is only y, so this is x squared. So I'm going to say for now it's okay. There is x squared, there is an x, there is an xy, and no x. Okay. Step 3. Greatest common factor. In all four. There isn't one. Very good. The only, a negative leading coefficient none. So the only strategy here is factoring by grouping. So this is really the easiest. Okay. I'm going to say that I'm looking at the first two, and then I'm going to look at the last two. However, this is not the only way. I have to try, if this doesn't work, I will try to group the first with the third and the second with the fourth. If that doesn't work, I will try the first to be grouped with the last and middle two. So there are 3 different options. First two, last two is one option. 1 with 3, 2 with 4, and 1 with 4, 2 with 3. And if none of these 3 work, then I'll say not factorable or prime. Okay, for now I'm going to try the first two. What can I pull out from the first two? Yes. What should I have in parentheses?
X plus 3.
If I do not get an x plus 3 from the other two before I even look, it's not the right way, or it's prime.
Right.
and I have to go back and regroup. I have to have in here a sign and a factor. If I forget the sign, I mess up the whole thing. So is there a common factor to these two that I could pull up in front with a sign and a factor so that this times this is this times this is this?
Would be positive y.
Positive y. That's it. Positive y times x is xy. Positive y times 3 is 3y. So now I have two terms, and they have a common factor that I will pull out. What is common? Same quantity in both.
X plus 3.
X plus 3. And what is left in parentheses? What is left from the first and what is left from the last?
X plus y.
Sorry about that. It takes you 15 seconds to check. X times x, x squared, x times y, 3 times x, 3 times y. You can always check these. Okay. Next problem, next question. Chris, we are picking from page 411, 412 in the hope that more people will show up so I can finish the equations.
No worries. Unfortunately, I don't have a book.
That's okay.
Maybe 26.
26. 26. Six x cubed minus 6x squared minus 120x. Again, I'm going to my strategy, and I'm asking myself, what is it? And the answer is yes. So I'll go through all these. These two make no sense here. Good. So it's a trinomial. Is it in descending order?
Yes.
Greatest common factor?
6.
6.
6x.
6x. How many terms will you write in parentheses?
3.
Exactly 3. We started with 3. We cannot lose any. Very good. Awesome. Okay. So what is left in parentheses?
X squared minus x minus 20x.
Careful.
Isn't it 120 divided by 6?
Good.
Am I doing it wrong?
No, you're not. But you said 20x.
Oh, minus 20. Sorry.
That's why I stopped.
Oh, okay.
Good. Perfect. Negative leading coefficient? No. So now we are here. First, I will try and see if a special product is applicable here. Look carefully. The special product requires the last term to be positive. In our problem, the last term is not positive. So you can say, no way. No special product is applicable here. Then I'm down to the one with the 1 as the leading coefficient. Since the leading coefficient now inside parentheses is 1, obviously I'm going to think of this, not of this. This specifically says the leading coefficient is not 1. But the leading coefficient in our case is 1. So then the procedure in this case is requiring us to find two numbers whose product is
1.
This is the product, negative 20,
Yeah.
and whose sum is
Negative 1.
always this. So let's see. How do I start thinking of this, about this? I always start with the product. Because the product is negative. Obviously, I cannot get a product that is negative unless I have a positive and a negative.
Right.
So now I'm looking at the sum. So one is positive and one is negative, but they're not too far apart. They are only 1 unit apart. So let's find two numbers whose product is negative 20 and whose sum is negative 1.
Positive 4 and negative 5.
We agree with positive 4 and negative 5? Both conditions have to be fulfilled. The product is indeed negative 20, and the sum is indeed negative 1. Both conditions have to be fulfilled. Therefore, now I will write 6x because I have to copy these two. And then what do I write in parentheses?
X plus 4x minus 5.
That's it. Any questions? Okay, next problem. 1 through 100. Anything you want.
Hmm,
77 it is. 77. 1 minus 8ab and minus 20 a squared b squared. Perfect pick. Okay. Back to the strategy. What is it? Correct. So all the focus will be here. Okay. Descending order? No. It's not in descending order. So a squared b squared ab, no ab. So negative 20a squared b squared minus 8ab plus 1 will be the first step. Secondly, I see there is no greatest common factor. Negative 20a squared b squared minus 8ab and positive 1 do not all have a common factor that I can pull out. However, there is a negative leading coefficient that I will pull out. What is left in parentheses?
20a squared b squared plus 8ab minus 1.
Awesome. Okay, it's all done. Now I'm here. However, I cannot fit a special product. Why? Because the last term is not positive. Even if it's a perfect square, I don't care. If the last term is not positive, I have to move on to this. But I can't apply this because the leading coefficient is not 1. So this is my last chance of factoring. If this method is not applicable, then a polynomial is not factorable. It's the last chance we have. So in this case, because the leading coefficient is not 1, it will be incorporated in the product, not in the sum. So this is negative 20, and the sum never changes no matter what the leading coefficient is, 1 or otherwise. The sum never changes. Positive 8. Again, I start with the product. The product is negative. Therefore, one number has to be positive and one number has to be negative. So,
would it be negative 2 and positive 10?
Negative 2 and positive 10. 10 and negative 2. Both conditions are fulfilled? Yes. The product is negative 20 and the sum is positive 8. Therefore, now the next step is not direct factor. Please carefully, let's think about this. This is not the next step. The next step is replacing the middle term using the numbers you just gave me. So 20a squared b squared plus 10ab minus 2ab and minus 1. This is what you gave me, and this replaces this with no change. There is no change. It's just that the change is the outlook. But 10ab minus 2ab is still 8ab. But now, do not go back and combine like terms. How many terms we see now?
4.
Yes, if you go back and combine them, you're annulling what you just did here. So here's what will be the next step. The first two terms have a common factor, which is
10ab.
10ab. What is left in parentheses?
AB.
With a 2, right?
Oh yeah, two AB plus AB. No. Is that right?
Plus 1.
That's it.
Oh, plus
What should I have coming out from the other 2 before I even look? The reason why I'm writing it first before I look is because I could mess it up. I could mess up the sign. Who knows what I'm going to write? To be on the safe side, I'm going to copy it first.
Correct.
I know it's there. How do I know? Because I found the relationship. I found 2 numbers whose product is this and whose sum is this. I know this has to come out from the other 2. Guaranteed. What is it?
2AB plus 1.
Now I look. Remember, I need the sign and the factor.
Take out a negative 1.
Very good. Indeed. Negative 1 times 2ab is negative 2ab. Negative 1 times 1 is negative 1. So now negative stays outside this negative. What is the common factor now that gets pulled out?
10AB.
That's not the common factor. The common factor present in these 2.
2AB plus 1.
Yes. And now what is left?
10AB.
Yes. Now I have to say this. Is it wrong to write it like that? No. It's the same thing. But I just want you to see the pattern and the order, and then you can branch off from there and do whatever you want. But this is the correct step. I factor out the common factor, and then this is what is left. But the other way around the world's fine too. Okay, next problem.
97.
97. In 97 we have a squared, a plus 2, plus 2, a plus 2. This is already set up for us. We really don't have to go through the strategy for this problem. I look, there are 2 terms, so that this is a product, and this is another product, and they have a common factor. I will put it up, and I'm done. What is the common factor?
A plus squared.
Yes.
A plus 2.
A plus 2 is the common factor, and what is left?
A squared plus 2.
That's it. There's nothing else. We can't do anything else.
For some reason, I thought it was like more complex than that. I didn't think it was that easy.
Yeah, that's all it is.
Okay.
That one's pretty much already solved.
Yes.
Maybe 99.
99 it is. X to the third minus 28 plus 7 x squared minus 4x. And after that, I would like to pick a few myself, if that's okay with you.
Sure.
Okay, so I see this is what goes to my mind. It's a polynomial, 4 terms. Nice, because the only thing I can do is factoring by grouping, but I have to go through the steps of rearranging everything. X to the third plus 7x squared minus 4x and minus 28. Then I look, it's in descending order, no greatest common factor, no negative leading coefficient. So my only chance is to go ahead and think. From the first 2, what will I pull out?
That would be x squared.
Good. What is left in parentheses?
X plus 7.
Good. What do I expect, hopefully, from the other 2? Otherwise, I have to go back and regroup.
X plus 7.
I expect an x plus 7. I'm hoping the x plus 7 is there. I need a factor and a sign. If it's there, I cannot fabricate it.
It would be negative 4.
Negative 4. So now what do I pull out?
X plus 7
Very good.
and x squared minus 4.
Now I have an x squared minus 4, which is a binomial. And I have to think in terms of the strategy for binomial. There are 2 with a difference. one is a difference of squares, the other one is a difference of cubes. Is any of those applicable here?
No.
X squared minus 4.
Yeah, because 4 wouldn't that be 2 squared?
Yes. And x squared is x times x.
Right.
So then I have x plus 7, and then
X minus 2 and X plus 2.
that's it. So always remember, when you're asked to factor completely. So till no factor can be further factored. Okay?
So for example, in that last parenthesis, if it was x squared minus 3 or something.
Then you would have not been able to.
Fully solved at that.
You would, yes, x squared minus 3 will have stayed.
Okay. Yeah, I gotta watch.
Even x squared minus 2 will have stayed, or 7. Yeah.
Okay.
But since both of them are perfect squares, and this is a formula that we have, a special product that we have to apply it.
Okay. Right.
Very good. So I guess now it's my turn. Let's say 89. X to the third, y to the third, plus 8z to the third. First of all, I know it's a binomial. When it comes to descending order, jury's out, because there are 3 variables. I don't know. I think it's good enough. Okay, the degree of this is 6, the degree of this is 3, so yeah, it's in descending order. Greatest common factor, no, none whatsoever. So if it's a binomial, after asking myself all these questions, then I'm here. Obviously, the one with a minus, the 2 ones with a minus they're not applicable here because this is plus. Now, this is not factorable. The sum of squares is not factorable. And these are not squares. I can't find anything that I square to get x cubed y cubed. There isn't such a thing. So my only option is this, if it works, the sum of cubes. So if it is the sum of cubes, I will have to present a binomial and a trinomial. If it is the sum of cubes, if this is the sum, the binomial has to follow the same sign. But the trinomial in the middle will have a minus. We don't ever discuss the last term. That is always positive. So if I factor the sum of cubes, then the binomial has to have the sum and the opposite sign inside the trinomial. My next question to myself is this. Is there something I cube to get x cubed, y cubed? Is there something I cube to get 8z cubed?
The top of the xy.
Very good. Indeed, xy, everything cubed means x cubed times y cubed.
The bottom one would be 2z.
The bottom will be 2z. And this is the binomial. What you just gave me, maybe knowingly or not, you just gave me the binomial. Now the trinomial, what is the pattern in the trinomial? Is this. Square this, put it here. Square this, put it here. What happens in the middle? Just the product, without the 2 from another formula. So when I square this, I put it here. When I square this, I put it here. And in the middle, just their product, without multiplying it by 2. So what do I have in the first spot?
xy squared.
Yes, but I have to write it as x squared, y squared, because I square a binomial. I'm sorry. I square a product, and I have to square each factor inside. The product.
Yeah, I don't know.
It would be 2z xy.
Exactly. 2xyz. Very good. xy times 2 times z. 2xyz. Very good. It's just everything you see here multiplied. And the last one?
It's 4z squared.
That's it. Let's look at another difference of cubes or sum of cubes. Let's say 88. 216y cubed minus z cubed. Again, I'll say when it comes to descending order, jury's out. I'm fine with y cubed to z cubed. Greatest common factor, no. Negative leading coefficient, no. Special product, I hope for a special product. I always hope for a special product. And I'm looking at the ones with binomial. This is a difference. So then I can have the difference of squares or the difference of cubes. Obviously, the sum has no place in here. So the question is this a perfect square or a perfect cube? There is nothing I can square to get z cubed. It doesn't exist. So obviously it's the difference of cubes. Binomial, trinomial. If this is the difference, this must follow the same sign, and the middle has to be positive. And the last one we don't even talk about, it's always positive. Okay, so now I have to discover what do I cube to get 216y cubed. And the answer is?
6y.
Perfect. What do I cube to get z cubed? That's silly.
Just z.
Just z. Now the pattern inside, remember, square this, put it here. Square this, put it here, and in the middle, just the product. Multiply everything you see. So, first term in the trinomial.
36y squared.
Perfect. In the middle.
6yz.
Plus?
Z squared.
That's it. Let's say you have doubts about your work and you're not sure, maybe you forgot the formula, blah, blah, blah. What do?
Multiply.
Right. So you will multiply this by these three terms, and you multiply this by these three terms. 4 terms must go away, and you'll get that. Guaranteed. Any questions? Any questions? Okay, now I would like to look at problems 80 through 84. Let's start with 83, 84, and then come back. Please choose from 83, 84, or I will. Okay. In 83, we have x squared minus 23x plus 120. Okay. It's a trinomial. It's in descending order. Greatest common factor, no. Negative leading coefficient, no. Special product, no. How do I know no? Because 120 is not a perfect square. So that's why this is not a special product. So then, because the leading coefficient is 1, I'm here with this. This is what I hope works. So I'm looking for two numbers whose product is very good and whose sum is negative 20. Now 120 is a big number. First of all, because it's positive, I know both numbers have to have the same sign. Since their sum is negative, I know they both have to be negative. Okay. I take 120 aside and come up with the prime factorization of that number. Here's how we do it. One option, not the only one. So I take 120, I see it's 12 and 10, I see it's 2 times 6, I see it's 2 and 5, and 6 is 2 and 3. Okay, so prime factorization, 2 times 2 times 2 times 3 times 5. All these n's are all prime numbers, and they're here, 2, 2, 2, 3, 5. Okay, now I want to find two numbers using all these factors. Who is two numbers, both negative, such that when I add them up, I get negative 23. Any idea?
Yeah, I'm not really sure. Oh, it's E,
And
15?
that's it. Do they add up to 23?
Yes.
And they're both negative. So negative 8 and negative 15. The product is a positive 120, and their sum is negative 23. So then how do I factor this?
X minus 8, X minus 15.
That's it. It will take you less than 10 seconds to verify that. Okay, let's start with, or continue with 80. (36) minus 13x squared plus x to the fourth. I have to caution you on this one. We have not seen not even one example of this. So you will have to be patient with this one. And then we'll look at other examples. So allow me to work on this to show you how to think about this and what is the process. And then we'll work on other similar to this one. Okay, here's the difficulty. It is a trinomial. It's not in descending order, but that's not difficult at all. So this is x to the fourth negative 13x squared plus 36. That's not a problem. No negative leading coefficient, no greatest common factor. However, the degree is 4. I am going to attempt one of the special products for the trinomial. I'm hoping that one of these works. However, since this is negative, obviously I'm only going to look at this. Then I'm going to check whether this is a perfect square and whether this is a perfect square. Is this a perfect square? This is a perfect square. What is it? X squared is not, yes, x squared. Very good. What is this?
6.
Very good. 6 squared. So what do you expect to get? There's no guarantee yet. But what do you expect to get?
Is it x squared minus 6?
Very good. X squared minus 6. Everything squared. Right?
So you just square the first term and the last term?
No. When you square this, you get 3 terms. The first term squared minus 2 times the first times
No,
the
I'm
second.
saying the numbers in the parentheses is the first term and the last term squared. Or they're square, right?
Yes, because the first term squared will be this.
Right.
Minus, we'll see in a moment, minus 2 times the first times the second will be this. Plus the second term squared will be this.
Right.
But I have to check the middle term, which has to be 2 multiplied by x squared multiplied by 6, which is 12x squared. I don't have 12x squared. Therefore, this is incorrect. I tried. I have to try. Okay. So now, here's the next step. I go back to this from scratch. Nothing that I tried worked. And I say this to myself, okay, let me take a look at this because this is the smallest power. It's in descending order. And I'm going to say, let y be x squared. So if I decide to replace this by y, the question is, what will this be?
Y squared?
If it is not y squared, I cannot use this procedure. So this polynomial, what is it, its degree? 4. So although it has degree 4, we call this polynomial quadratic in form. It's not quadratic. We know it has degree 4. Quadratic means degree 2. But it can be presented or replaced by a quadratic expression. What quadratic expression can I replace this by?
Y squared minus 13y plus 6.
Why would I want to do this? I want to change the variable. I want to use the substitution because this, I know how to factor. This, degree 4, not really. So, how do I factor y squared minus 13y plus 36? I know it's not a special product, so I'm trying to find two numbers whose product is very good, and whose sum is very good. The product is positive, therefore both signs have to be the same, but their sum is negative 13, so then I know both signs have to be perfect. So two negative numbers whose product is 36 and whose sum is negative 13.
Negative 4 and negative 9.
Very good, awesome. So then this is factorable. How? Since the leading coefficient is 1, I don't have to use the long procedure. It's a straightforward procedure. So what is the answer for this in y? Very good. Good. However, we cannot leave the answer in y. Y is our baby. We created it because we wanted to simplify the procedure and simplify the method. But we cannot leave the answer in y. But I know what we denoted by y. So what will I replace y by in this expression?
No, probably x squared. Right?
Exactly. That's why we said let y be x squared. Very good. So then this becomes, can anyone dictate now?
X squared minus 4x squared minus 9.
Very good. However, it's not done. How come it's not done?
Because you can break down x squared minus 4.
Yes, and x squared minus 9. How?
Well, the first one would be x plus 2x minus 2. And the second one would be x plus 3x minus 3.
So, a lot of steps here because the degree was 4. And because we had difficulties, we couldn't use a special product. And because degree 4 is not as easy as factoring degree 2. The last part was that that expression, that trinomial, was quadratic in form. We were able to replace it by a quadratic expression. Not all polynomials, degree 4, are quadratic in form. So let's look at another. Let's say 81. And on 81, I would like you to walk me through x to the 4th minus 14x squared and minus 32. It's in descending order, no greatest common factor, no negative leading coefficient, no special product. It's negative 32 at the end. Degrees 4. So what will you think or hope for? That this polynomial is, although it's degree 4, you're hoping that it is also quadratic in form. It can be replaced by a quadratic. So what will you say? You can use any letter you want, but x. Okay, let y be, please.
X squared.
Very good. So only if this can be replaced by, if it cannot be replaced by y squared, It means that the polynomial is not quadratic in form. If I cannot replace it, I have to find different avenues of factoring it. But can I replace that by y squared? Is it true? Not because I want to replace it. Is this true?
Mhm.
Good. So then this new polynomial is,
X squared.
but y. I cannot have x and y.
Oh, Y. I'm sorry, let Y be static.
Once I start with x, when I convert into y, I can no longer have x. And then at the very end, I'll come back.
Do we always have to convert into Y, on the quadratic form?
You can use any other letter, but if this is not t squared and this is t, then you will not be able to use the method because it means that the polynomial is not quadratic in form. For example, if I have this, x to the third minus 14x squared minus 32, there is nothing we can do here. Why? Because if I denote, let's say, this by t, this does not equal t squared. So this polynomial is not quadratic in form. Therefore, I cannot use the method that we just are trying to apply. So what will you say is the new polynomial? Y squared
Minus 14Y squared.
minus 14,
Y
very good,
minus 32.
minus 32. This, I know how to factor. Good. So the product is negative 32, the sum is negative 14. Can I find two numbers, one negative and one positive, because the product is negative?
Negative 16 and 2.
Very good. So then how do I continue here?
You say x squared, y minus 16, y plus 2.
Very good. But now I have to go back to my substitution.
Right, which would be x squared minus 16, x squared plus 2, and then you gotta break that one divided, of course.
This one I can't, it's a sum, but this one I can.
Which would be x plus 4, x minus 4, and then x plus 2 for the last.
X squared plus 2.
Oh, yeah.
Very good. I think we should work on one more and move on to equations now. Okay? So let's work on one more. That was 82, which is x to the fourth minus 22x squared and minus 75. So here's what we did, Corey. We replaced this by y and this by y squared. This was y squared minus 14y minus 32. And we figured out that it's negative 16 and positive 2. And then we replaced y by x squared and y by x squared, and we factored this into this.
Okay.
And this is one more here before we look at equations.
I have a question.
Yes? Yes.
So I did solve some questions before,
Yes.
for like what we're doing
Yes.
right now, and
Yeah, this one was a perfect square.
Mm.
Because this is a perfect square and this is a perfect square, so you wrote x squared plus 3.
yeah. But how do you tell the difference between this one and this one?
This has degree 4 and this has degree 2.
So it doesn't matter whether it's degree 4, you can solve it the same way.
In the same way, but this is x squared plus 3 and this is only x. Yes, they are different. Is that okay?
Mm-hmm.
Perfect. So let's work on the